Hello, Professor. In this video, I would like to explain the process of each problem with its formula and the process to its answer. Let's get started with the first problem. My name is Darom. To solve this, we have to use the binomial probability formula, which calculates the likelihood of a certain number of success. However, in this case, driver with invalid license in a fixed number of trials. For A, find the probability that none have an invalid license, which is Px equal to 0. To calculate the probability that none of the 30 drivers have an invalid license, we can use Excel formula to save this time and ensure that we have to correct the calculation. So the formula we have to use is the equal binom.this kn pi cumulative, and there are two types of cumulative. One is the false or PDF. We use 0 and use 1 if it's true or CDF. As you can see in the answer I provide, Px equal to 0 equal to binom.this 0, 30, 0, 0.15, and 0, and the answer is 0.008. For part B, we have to find the probability that exactly one has an invalid license, which is Px equal to 1, and to find this probability, we need to use the formula binom.this, which is equal to binom.this 1, 30, 0, 0.15, and 0. So we got the answer is 0.04. Lastly, for part C, we have to find the probability that at least 2 have invalid license, which is P equal to X bigger equal to 0. To calculate it, we need to use the complement rule. Px bigger equal to 2 equal to 1 minus Px smaller than equal to 1. And before getting the final answer, we can find Px equal to 1 equal to binom.this 130 0.15, but to make it short, let's put it together by 1 minus Px smaller equal to 1, then we got the answer 0.952. So moving on to problem 2, as you can see, based on the problem, we have to find the sample data. First, we need to find the sample average. We can use the formula x dot bar equal to x1 plus x2 plus x3 plus until xn, then divide by n, the number of data. So after the substitute all value in, we got the sample average equal to 181.75. However, we can use Excel formula, which starting by typing equal average and put the data range. Moreover, if the question asks to find the standard deviation, we can use Excel formula equal to standard deviation dot s and put the data range. We get the answer. As you can see, the answer I provide used in the Excel and is equal to 10.47. By this way, based on the problem, we have a sample size equal to 12. Moreover, another point, the question asks to find the confidence interval which include the lower and the upper limit. In this case, we can use the formula x bar plus and minus t alpha over 2 multiplied by sample standard deviation and divide by the square root of n. We have 1 minus alpha equal to 90%, so alpha equal to 10% equal to 0.1. To find the t alpha over 2, we can use the exact formula t dot inv 1 minus 0.1 over 2 degree freedom 12 minus 1, then is equal to 1.796. In this final step, we can put the value in the formula of confidential interval to find lower and upper limit. Next is the problem 3. In this problem, we ask to analyze whether the number has volunteer per week is independent of the type of the volunteer. And we have to perform a three-square size so of independence. So I will provide this step by step to do this problem. The first step is to define the null hypothesis H0 and the alternative hypothesis H1. The null hypothesis assumes that there is no relationship between the type of volunteer and the number of hours they volunteer. In the other words, their two variables are independent. So we can write H0, the number of hour volunteer is independent of the type of volunteer. H1 is the number of hour volunteer is not independent of the type of volunteer. In step 2, we have to figure it out the level of significance if the question doesn't mention. So we can consider as it equal to 5% equal to 0.05. Moving on to step 3. Since the data involve a category variable and the goal is to determine independence, we use the chi-square test of independence. Next, we can use the chi-square formula to find the test statistic. However, first we have to compute expected frequencies row table multiplied by column table and divide by the total. Then we got another table called expected value. And to find the test statistic, we need to use formula sum of actual value minus expected in square and divide by expected value. Then we got the test statistic answer is 12.027. Moreover, to find the degree freedom, we have to look at the table and we take the number of row minus 1 and multiply by the number of column 1 equal to 3 minus 1 multiplied by 3 minus 1 equal to 4. In step 4, we have to make a decision whether to use a critical or p-value. If we find p-value, so we can compare it with alpha to reject HO. In this problem, it asks to find the p-value, so we get exact formulas. His dot this are t test statistic and degree freedom. Then we got the p-value equal to 0.017. Since p-value smaller than alpha 0.05, we can reject HO. Last step in step 5. In conclusion, we can conclude that the number of hours is not volunteer independent of the type of the volunteer. Moving on to the last problem is problem 4. First, we have to read through the problem as we will get the given value like mean, standard deviation, and sample size. So we start by defining the hypothesis. Null hypothesis H0, the true mean bar purchase when the music is slow is less than or equal to when the music is fast. Next is alternative hypothesis H1, the true mean bar purchase is higher when the music is slow. Step 2, level of significance. The level of significance alpha is given as 0.05. This means that we are willing to accept a 5% chance of rejecting A0 when it is true. Next is step 3. We need to figure out the type of the test. Since the sample size are small, N1 equal to 17 and N2 equal to 14, and the variance are unequal. We use a two-sample t-test for unequal variance. The test statistic formula in this case is t equal to x bar 1 minus x bar 2 divided by the square root of s1 square divided by n1 plus 2 square divided by n2. Then we will get the answer for the test statistic equal to 2.104. For the degree freedom, as you can see in the answer, it is the little complicated formula, but it is not a big deal since we have all given elements to compute this. In step 4, We have to find the p-value by using the Excel formula t.this.rt characteristic and the degree freedom that we are found above. So we got the p-value equal to 0.02, smaller than alpha 0.05. We reject the HO. In step 5, we can conclude the true mean is higher when the music is low. Thank you.